Hey everyone, and welcome back to the channel. Today, we're tackling a phrase that recently exploded across hacker news, igniting a firestorm of debate, and frankly, touching a raw nerve for many of us in the software development world. The statement, "Code was never the hard part." Now, if you're a programmer, an engineer, or really anyone who's spent more than 5 minutes trying to make a computer do something useful, your immediate reaction might have been a snort, an eye roll, or perhaps even a full-blown existential crisis about your career choices. Because for many of us, code is often the hard part. It's the intricate logic, the elusive bugs, the complex architectures, the relentless pursuit of performance and reliability. It's the silent battles waged against compilers and the late nights spent wrestling with documentation. To suggest it was never hard feels, well, a little insulting. But let's be fair for a moment. This phrase, like many contentious statements, often comes with an implicit context, a nuance that sometimes gets lost in the heat of online discussion. When some people say code was never the hard part, what they might genuinely be trying to convey is that the challenges surrounding software development, things like communication, project management, understanding user needs, navigating organizational politics, or dealing with people, these soft skills, or meta problems, are also incredibly difficult and often overlooked. They're trying to highlight that building great software isn't just about writing code. It's about the entire ecosystem of human interaction and problem solving that enables that code to exist and be useful. And to that, I absolutely agree. Communication is hard. Project management is hard. Understanding complex business domains is hard. No one is disputing that these aspects are critical and challenging. However, the bluntness of the statement "code was never the hard part" strips away this crucial nuance and, intentionally or not, trivializes the very craft that underpins our entire digital world. It implies that the act of turning abstract ideas into functional, performant, secure, and maintainable software is somehow trivial, a mere clerical task that anyone could do if they just understood the real hard parts. And that, my friends, is where it becomes deeply problematic and, yes, an insult to the countless hours, the deep theoretical knowledge, and the sheer intellectual effort that goes into writing good code. Let's break down why this statement is so dangerous and flat out wrong for the vast majority of software development efforts. Firstly, technical complexity has exploded. Think about the systems we build today compared to even 10 or 20 years ago. We're not just writing a simple script to automate a task. We're architecting globally distributed microservices, processing petabytes of data in real time, building highly concurrent and fault-tolerant systems, dealing with intricate security protocols, optimizing for minimal latency on a planetary scale. These aren't simple problems. Designing robust, scalable, and secure systems requires a profound understanding of algorithms, data structures, operating systems, networking, distributed computing principles, cryptography, and often, highly specialized domain knowledge. Writing code that implements these complex designs, ensuring it's efficient, bug-free, and handles edge cases gracefully, is incredibly challenging. It's a continuous learning journey where yesterday's cutting edge might be today's legacy debt. Consider the sheer breadth of knowledge required for a modern software engineer. You need to understand multiple programming paradigms, be proficient in several languages, navigate complex frameworks, grasp database internals, know about cloud infrastructure, understand front-end rendering, optimize for mobile performance, and debug across multiple layers of abstraction. Each of these areas can be a career in itself. To dismiss the coding aspect as never the hard part is to disregard this vast landscape of technical expertise. Then there's the asterisk hidden difficulty of writing good code. Anyone can write some code that technically works, but writing code that is clean, readable, maintainable, testable, extensible, and performant, that's an entirely different beast. This is where the artistry and engineering discipline truly shine. This is where you separate the casual dabblers from the seasoned professionals. Crafting elegant solutions, refactoring messy modules, optimizing critical paths, ensuring proper error handling, designing intuitive APIs for other developers, these are all incredibly challenging tasks that demand deep focus, experience, and technical prowess. They might not be the problems that management sees directly, but they are the bedrock of sustainable software development. Poorly written code, even if it works, becomes a monumental, hard part down the line. Slowing down development, introducing bugs, and draining team morale. So, while communication might seem harder initially, poorly written code creates a communication nightmare for every developer who has to touch it later. And let's not forget asterisk debugging, the process of finding and fixing bugs, especially in large, distributed, or highly concurrent systems, is often a Herculean task. A single semicolon out of place, a race condition hidden deep within asynchronous calls, a memory leak in a critical service, these can take days or even weeks to pinpoint and resolve. It requires forensic detective skills, a deep understanding of the system's internals, and immense patience. Anyone who claims debugging isn't hard has clearly never spent 48 hours chasing a Heisenbug that only appears on Tuesdays at 3:17 a.m. during a full moon. This is code, and it is undeniably hard. Another crucial aspect is asterisk system design and architecture. While often considered separate from just coding, the two are inextricably linked. An architect might design a beautiful system on a whiteboard, but translating that vision into concrete, functioning code requires immense skill. The coding